Okay, I'm happy to introduce today's speaker, Dr. Kandaswamy, Swaminathan Kandaswamy, Assistant Professor at Emory School of Medicine. He has a degree in lots of engineering degree from mechanical engineering, a master's degree at North Carolina State University in industrial engineering, and Ph.D. at University of Massachusetts Amherst, also in industrial engineering. And currently his focus is very much on electronic health records, which is an issue and that is very near and dear to me, being a clinician, and not only looking at how to use data to be able to learn things about patients, but also learning how to make EHRs better themselves. And this is a really hot topic right now. We know that a lot of people are burning out because of EHRs. So if you want to join at slido.com, that code there, I'll also put that in the chat, that you can also answer. Type in any questions that you like, or if you can put them in the chat. So without any further ado, I would like to introduce Dr. Kandaswamy, and his title of his talk is Application of Human Factors Engineering for Better Clinical Decision Support.
Thank you for that introduction. Thanks everyone for joining. So today I'll talk about our journey with electronic health records so far, and then talk about how human factors engineering can probably help with some of the issues that we are facing. And if you can join at Slido to post questions or answer some of the polling calls, that would be great. So our journey with the electronic health records, in the late 90s, the Institute of Medicine came up with a report that said how bad or unsafe our systems were, and it potentially highlighted systemic issues within healthcare. And we thought electronic health records can help with some of those issues, and there was a great push to adopt these systems. And we now know that these are ubiquitous. But as we sort of moved forward with adoption, we actually had lots of unintended consequences. There was reported increased mortality after implementation of these systems. We have also had reports on how these systems facilitate errors. It's not only affecting patients, but it's also affecting clinicians. And as Amy was talking about, this we have systems that have made clinicians do lots of navigation, search for information, essentially putting them on an impossible place to work at, and creating cognitive burden for them, and essentially leading to burnout. And so I wanted to say how human factors maybe help with some of these issues. And to start with, what is human factors? Human factors is a scientific study that understands the capabilities and limitations of human performance, and its application is to help with using that knowledge to design of systems and processes in order to minimize errors. So it draws from a lot of other disciplines, like engineering, psychology, economics, and so on. And this is, before we sort of get into some of the ideas from human factors engineering, I want to start as thinking about how do we approach design in general? And if you can maybe answer this question on which design you think is better for clocks. Okay, let's see if we have any responses. Okay, it seems people prefer analog as a design option. And to me, the answer is actually, it depends. It depends on what the goal of our design is. If we are thinking about getting precise values, then probably a digital design is better. But if you are looking at aesthetics, or if you are looking for knowing what the motion is in terms of how much time has elapsed, then analog devices are better because you can actually see the clock moving, and that gives you a sense for how much time has elapsed. So design is essentially a trade-off between different goals that we have, and we often have situations where we are going to have to compromise between the different things that we are interested in, and we may not have optimal solution for everything. Um, and um, and so I'm going to start with some of the examples that we may have in everyday life to sort of start thinking about how common practices or common designs can lead to errors. So on the image that you see on the left here, you see it's asking us to pull, but there is no affordance offered to actually pull the door, and it's setting up us for failure. Similarly, the image on the right, it's you have very similar looking spray bottles, and I may grab the bug spray instead of a cooking oil, and that can lead to serious errors. And this is also common in healthcare. We have had situations where we had medication errors because we grabbed long vials that looked very similar. Again, this is sort of an example of design that was done without thinking how people would actually use this in practice. And this is also common for us in healthcare, where we often see systems designed without taking into consideration of how people would actually use it in practice. And it's not just workflow integration, but it's also about how we present the information. If you look at the image on the left, this is probably the most common kinds of signs that you see about parking, and it's very hard for us to actually determine whether we can park at a given time or not. Versus the one on the right side, it actually does that for us. It makes all the information processing for us, and it provides us the information we need, which is a go, no go for whether we can park or not. And so you can see how good design can actually make things better. However, I also want to sort of caution us, looking at these examples, we may think it's just common sense, but design is more than just common sense and intuition. Intuition is often a poor guide for design, and it's most often learned based on our experiences. And so what I think as intuitive may be very different from somebody else. And it depends on people's expertise, their skill levels, and so on. Also, human factors engineering has, because of its sort of scientific base, it can actually link human characteristics to design specifications. For example, we can know which colors are easily distinguishable, which fonts are good for our design, how loud an alarm should be when we are designing something to capture an attention, how much weight can a normal person lift without causing injury. So there are lots of things that we can actually know a priori instead of having to do trial and error. This is an example which you may have seen about how information was presented before the space shuttle was launched. This Challenger space shuttle unfortunately met with a disaster because of O-ring failure. And the information that they presented to the team making the decision actually showed multiple things. They were trying to convey where the O-ring was, what temperatures it was on, but also whether they had failures or not. And it was too much to process, and it didn't necessarily convey the point that they were trying to get across. And if you look at this image here, it's very sort of more clear from here that as the temperature drops, you're going to have lots of O-ring failures, and that may lead to problems. And if they had seen probably this version of the same data, then they may have delayed based on the forecasted temperature on that day. Here's another example from healthcare, where we see a medication error because of how this actually happened because of multiple reasons. This was they had an opioid medication that was initially prescribed in 2 ml vials. They had 2 ml vials. Providers used to order half a vial for getting 7.5 mg dosage. But then the manufacturer changed to 1 ml vials because they were seeing often that the people were using just half a vial. So they changed to 1 ml vials. But in the logbook that the hospital had, they still kept it as 2 ml vials in the logbook when it was 1 ml. And the providers ordered half a ml as they used to, because they also didn't know that they had changed to 1 ml vial doses. And this led to patients getting inappropriate dosages. And you can see here, there are problems in multiple levels, and it's both, many of them are systemic errors. And so there are factors that can be sort of both at a human level, but also at systemic levels that contribute to errors. Of course, there are sort of problems that may have occurred because of sort of malicious intent, or acting with under the influence of alcohol or other things. But we often are in a situation in healthcare where people try to do the right thing, but they end up with bad results. And the things that we can control are the conditions in which we work. And there are a lot of factors that we can control. I'm going to move to what are some of the things that we are probably can't control and why that's the case, and what are the things that we can control. This is a sort of an image to illustrate how we process information. Can you respond to this question on what do you see here? Do you see Lincoln or do you see women? It seems to be 50-50. More women maybe. Okay. And for us to know that this is Lincoln, you need to actually first know that you're looking for Lincoln, and you need to abstract it. So what we are using here is called as a top-down processing, where you already know what you are looking for and you're trying to match that. Versus if you're looking, if you're seeing a woman here, you're actually taking that information from bottom up, which is what is displayed to you, and you're trying to see that. And we do this most of the times where we do both bottom up and top down processing, but it has huge impact on how we do things. This is an example where if you were to read the letters as such, like purple, yellow, red, it's probably much more easier, and you're doing top down processing. If you are trying to process information bottom up and trying to say the color, instead of reading that letter, it's much more harder. But when we present information to people, we want them, it depends on the whether we want them to get new information out of it, or are we going to help them do a thing based on what they already know. For example, if we are designing order sets and we want to actually use clinicians' knowledge, and they are going to use top-down processing because they already know they want to order this test, or they already know that this is the diagnosis and they want to get at guidelines for that. So if we are designing something for that, then we should enable our search to match what they would expect from top-down processing. Versus if we are to give them new information, like, this patient may be at risk for some exposure or other things that they may not know, but it is something that they have to learn, then we are going to do with bottom-up processing, then that has to catch their attention. This is a little bit theory on how we process information. And generally, we have a stimuli and then our sensory memory sort of gets that information, and we get only 3 to 7 chunks of information at a time when we see something. And then we need to attend to it in order for us to actually sort of know more about it. And then that goes into our working memory, and we can at a time process about 7 to 9 chunks of information. And why is this important for us to know? Because if we are trying to, let's say, design an alert for physicians, we need to make sure that we capture the attention of whoever is seeing that, because if the information is not attended to, then we are going to lose that information. And even if we have the attention, they can only process information in chunks. So instead of writing up a whole paragraph on alerts, we may want to just do like bullet points, so that it's giving information to them in a way that they can process. Let me see if I can actually play this one. Can you guys hear the sound?
Can't hear the sound.
Sorry?
Oh, we can't hear the sound. We can see the video, but there's no
Okay,
sound.
so you can see the sound. So let's just try to count the number of times the ball is passed. Okay, so the correct answer is 16 passes. You may have noticed the gorilla. Did people see the gorilla?
Yes.
So this was just to sort of show how selective our attention is when we are trying to look for information. And this often happens in healthcare because we are trying to get at multiple things at a time. So I want to sort of show more examples of how valuable we are with trying to do some of these things. When we have, which line do you think is longer? I don't have a Slido for this one, just for the sake of time. But you may think B is longer, but they are actually of the same size. And that is because of how we process information. We sometimes are fallible to sort of biases in how we estimate distances. And then, but these are actually useful for us when we try to have these, what I may call as shortcuts for us to process information, because it allows us to do things much quickly. I'll leave this screen for a second. Try reading the letters out and see if you can read them. So you can see, as you sort of try to read this more, even if the letters are not arranged in the order you expect, you can still read them. And this helps us to accomplish a lot of things. And this also happens in us doing information processing for other cases. But because of those shortcuts that we have, we are fallible to what are called cognitive errors. And these can be things like, we do faulty assessment of how likely something is to happen, or we may not consider all of the relevant possibilities when something happens. And I'm going to talk about a couple of these examples. One is availability error. This is when we try to choose the first thing that comes to our mind, because that's the first thing that we know about, and then we forget about what of the other things that may have happened with the patient case, and that may lead to errors. And then there is anchoring error, which is when clinicians, cling to their initial impression instead of trying to look at other contradicting data that may accumulate over time. There's confirmation bias, which is, you accept only the first thing that you see, or you accept data that supports your hypothesis and ignore data that doesn't. And confirmation bias happens often for us when we try to do cross-checking with people. And that is why it's important. Let's say if you are designing a process that has dual checkoff, we need to make sure that they are independent. So there are lots of sort of little things that may change how we perform an activity, but knowing some of these biases will allow us to put safeguards around how we do them. Now that we have seen some of the sort of human performance factors at individual level, I want to draw our focus on systems thinking. And usually it's not just the humans working sort of in silos that are going to create outcomes that we are interested in, but it's actually how we interact with many things, what we call as work systems. And these includes the technology and the tools that we use to do, like the electronic health records, which we may use to do the tasks that we want to do. And then there's the environment in which we work. And the environment can be can have lots of disturbances, or it can be that we have interruptions, or it can be a place where it's too noisy so you can't focus, or you may have poor lighting that may lead to increased stress or things like that. And then there's also organizational factors, like what's the policy that we have regarding certain patient care situations. And that may, even if you have the same tools and technologies with the same people, working in a different organization might change outcomes based on how that determines what we do. And then these interaction leads to the processes that we are interested in, which leads to our outcomes of interest. And the reason we want to think about that is because it is the interaction that leads us to an outcome. And we want to sort of work on design of any clinical decision support, or for that matter, any EHR build. We want to understand who our users are, what their tasks are, and then sort of lay out what environments they work in, what is the interaction between all of these components, and do they facilitate or are barriers to what we want to achieve. And this helps us and gives us a better understanding of what we want to design for. Once we have that, we then want to look at design prototypes, and then we want to actually use some heuristics to see if they, or use these guidelines to see if they match these evidence-based guidelines. And there are a couple of them that are for CDS, which is Osharaf's 5 rights, and there is also David Bates' 10 commandments for effective CDS. And then there is a generic heuristic for user interface designed by Nielsen, which gives us a set of 10 heuristics to help and have a gut check on if that interface is good. The 5 rights of the CDS are to see if we are providing the right information to the right people in the format that we want, using the right channel. And channel here can be, you can have a electronic health record version, or it can be through like a paper edition support, or it can be through like outside of electronic health record through like other devices. And we want to make sure that it's in the right time of people's workflow. And this doesn't get at all of the important aspects of CDS, but it does get into most of the things that we want to do. So here is a example alert. What heuristics do you think does this not meet? I'll put this one here. Okay.
Sorry, can you display the screen
Yeah.
again? There you go.
Yep,
It's a little hard to
sorry.
vote without seeing it.
Yeah. So this is an alert to asking users to place an order for type on screen for blood type. I'm gonna sort of move forward just for the sake of time.
Okay.
If you see here, it's actually seen by RTs, respiratory therapists, and they are not people who are actually going to order like type on screens for patients. So obviously it's violating, as sort of an example, right? It's violating who you want to show this to. Also, it doesn't show us why I need to order this type on screen or what is. It does show here that they don't have results here, but it can also be that they have already ordered, or there may be other reasons why it may not be appropriate to get. So it actually doesn't provide information about why we want to do certain things. And then this is sort of another set of heuristics that may help with user interface design. And this is, there are 10 heuristics here. The first one is providing visibility of system status. This is to show users where they are at when working. And if you are sort of used to browsing, or if you're downloading something, you may know how much the downloading has happened, right? It shows a percentage of where you are in the process. And so you know what to expect and you know what to do later on. If you don't know what the system is doing, then we don't have a way to know where we want to go next. Similarly, we want match between what is called a system and the real world. And as an example here, if you see, they have an image here for showing stoutops. You may have seen certain stoutops that are difficult to access the controls because they don't match with how the layout is for the actual heating elements. But if you actually match them to how they are seen, then it's much easier and you know what exactly to control for. And then the next thing is providing users with control and freedom. And this is often to help them have an exit. If they made an error, they can have some recovery on what they want to do. And then using consistency and standard, this is more important because if you are going to use synonyms or if you are going to have a different structure for each of your alerts, then people will not know what to look for where, or they may not understand some of the terms that we use, and that may create confusions. The next thing is error prevention. Error prevention is always better than error correction. So we want to make sure that if by design we can create a system where we don't have errors, that is better. We were just working on a project where we tried to get people to get consent on for HIV testing. And initially we had an alert for asking people to go verify that they had a consent after they put an order for the HIV testing. And if sort of the users skip that, then we are in a place where we are trying to rectify the error. But a better design approach to that would be to actually have order questions so that they cannot place the order without having confirmed that they'll either have a valid concern or that they don't need a concern for those exceptions. So you can think of sort of situations where you can by default make design in a way that you would prevent errors rather than trying to correct them after something has happened. And most often alerts generally, which is actually a problem with sort of burden for clinicians, is actually trying to do error correction. So when we are thinking about CDS in general, we want to make sure that we are thinking of steps a priori that can help with error prevention and not trying to do rectification. And then allow for recognition rather than recall. And this is because we are good at recognizing things rather than trying to recall what is the actual dosage for a certain medication. And then there is flexibility and efficiency of use. And this is to provide multiple ways for users to get at a certain thing. So that way, if you are an expert, you can use those shortcuts to get there, but also it helps move things faster. Or if you are somebody who's new to the system, it also allows you to go through a specific sequence of steps and you can still get the work done. And then aesthetics and minimalistic design is to just make sure that you are not utilizing crucial real estate for important information with irrelevant data. And then the next thing is trying to recognize and recover from errors. This is obviously to make sure we want to make sure that users don't do any sort of mistakes, but even when they do, we want to make sure they understand where they are, like what the mistake is, and recover from that error. So it's easier for them to proceed. And finally, documentation to help them know what to do. So for example, if we are building an order set or an alert, we may want to have a documentation in place for why we built that alert in the first place, or what was the evidence behind trying to say something in the order set. So later, if somebody had a question, they can actually go back and make sure that we had the right things in place. Okay. And I want to skip this one for a second. And so now that we have seen some of the sort of heuristics that may help us think through sort of prototype designs, I actually want us to go through a process of how we may actually test it once we have a design in place. So inside usability testing is actually testing it where people work. And this is a little different from traditional usability testing, where you take time out, you schedule time for these testing sessions and try to sort of understand how users would behave. And generally, usability testing helps us to actually see what people would do rather than actually ask them how they would use it. Inside usability testing is helpful because we are actually going to test them, like if I'm doing this in inpatient setting, I'm actually going to go to floors where people are working, like in the afternoon when they are probably not as busy, try to get them for like 5 minutes, and you get a feel for their environment where they are working in, but you also can do this more rapidly. And this helps us with a lot of things. One, it validates the content and the functionality of your build. It tries to identify errors if you have any. But more importantly, it helps to see if the design that we came up with matches with users' mental model and if the design would fit their workflow. And these can help us with sort of updating our design through feedback from users, and also develop empathy for the struggles that may have when trying to use a system that may help us come up with better alternatives. And when we do usability testing, we want them to sort of use a piece of decision support that we have built and we observe them do something with it. And then at the end, we ask them for feedback. There are questions that we can ask them on the CDS itself. And this is an example of a CDS to promote influenza vaccine uptake, where we had a pre-checked order in admission orders for providers, so that if somebody is eligible for vaccine, then an order group is automatically added to the admission order set for those eligible patients, and then they can probably administer it later after getting consent from the families. So what questions do you think we can ask on this piece of decision support? I'm going to go back to give the whole.
When you go back, the survey goes away.
Oh, I didn't know that. Sorry.
Yeah, so that's why you're not
That's
getting
why.
answers. As you show this slide, and
Yeah.
we can't see the answers. And when you go to
Okay.
the answers question slide, we can't fill out the survey.
The
So
survey. I'm
this is,
sorry. This is
it's tough.
yeah.
If I enlarge it, I can read it.
How do I enlarge this?
No. Well, people on the browser, because
Oh,
you
okay.
are displaying it. You're displaying the screen in the survey.
Yep. Okay. Okay. Yeah. Sorry. So we have some answers in here. Sorry, probably I didn't make the question clear enough. So let's say we are testing this with providers and they are actually using this piece of decision support, and we want to observe and see if they would actually place the influenza vaccine orders. And so if we are sort of looking, there are multiple pieces to this piece of decision support. And if you see here, there's actually this link to the state immunization registry that actually gives information. If you go to this hyperlink, if they had questions on, did they actually get an influenza vaccine this flu season? They wanted to confirm that, they can actually go into this one and they can verify whether this is correct and whether this is applicable to this patient. And then you have multiple recommendations for when to give influenza vaccine, whether it's okay to give the patients are on steroids, if they are immunocompromised and if they have egg allergy and things like that. And these are all references to those specific literature on what to do in those cases. And then interestingly, we had initially thought about giving this as an order. At first, we actually put this as dose immediately. And then people felt that while getting admitted, it may be too much because we actually want to do and understand why the patient is coming in, whether it's okay to give vaccination for those kinds of situations. And so we then moved this to dose at the next day in the noon, so that when people are getting admitted, we still have some time to figure out whether that's okay to do. And if it's not, then we can cancel it at a later time. And do providers actually recognize that that's what the workflow is going to be? Do they actually use it that way? We realized after this happened 3 years before, And we have made multiple sort of other interventions for this one over the years. And we actually realized that people had a tendency to push medication to the discharge because they wanted kids to get better as they move through the hospitalization course. And so to enable that, we had to come up with another piece of decision support, because this did help us in getting to many patients, but there were some patients for whom they wanted to get a discharge. So while we understand where this may fail in terms of workflow, we can think about potential solutions. Okay, so the whole process that I have sort of shown some examples in bits and pieces. So I want to sort of reiterate what the whole sort of process looks like. So we want to start with the problem, understand what the problem is, do a workflow work systems analysis. And once we have a better understanding of who our users are and what their tasks are, then we want to create a prototype design that maps to the users and their tasks, and ensure that those goals are met. And once we do that, then we can adopt those guidelines and see if there are problems in our design, and anticipate if there are going to be any problems that users will run into, and change our design accordingly. And then we want to simulate and observe how people would use this in practice, talk to them, get feedback, and then change based on their feedback, do some rapid prototyping, and then test it in real world situations. So it's better to fail early than later in the workflow, because if we did everything first, we thought that it's going to work, and we put this in production, one, it's going to cause unintended consequences. The other thing is now we have to take it back and we have to rebuild the thing again, which is going to create a lot more problems. And so I'm going to talk about an example project where we have adopted this technique and show the steps in more detail. So the aim of the project was to improve documentation of key properties for central venous access devices. And that was to enable appropriate use, care, and maintenance of the line, and also removal at the end. And so if you think about what the tasks are involved in a CVAD, it starts with sort of recognizing that the patient needs one, and then a physician or somebody orders it. Then somebody places the central venous access device, and then we need to document that placement. And then once that is done, then that documentation helps with sort of documenting for other uses, but also once the line is in place, then people can use that documentation for use and care. And then we need to have a risk assessment of the line itself as an ongoing activity. And then at the end, we do removal of CVADs. If you think about our users who do this, who has the knowledge for doing it? So we have the actual properties of what the CVAD is with the people who place the actual line and people who do risk assessment. People like, floor nurses may not know what are all the, properties, like whether that is, tunneled or not. Sometimes you may see it if it's actually tunneled. Sometimes it may be hard to find on some patients. The people who have the information about what the properties are not the people who actually need it, right? The people who need to use that information are people who want to use that line, who want to do like maintenance of that line, and people who have to remove it. So the knowledge is with people who do different tasks, but versus the need for that knowledge is with other people. And this is just to show how that interaction happens. And so what we did was we tried to get users to actually do documentation on realistic scenarios. So we came up with certain scenarios where if the line is to be documented by a nurse, but was placed by an IR team, but they didn't have the documentation of the actual properties, then the nurse has to actually do the documentation. They may have to then go back to the line placement note, look for the documentation. If that documentation is good, then they can grab that information, but they still have to search through that documentation to get that information. So we came up with multiple scenarios to see how people would document. We observed, and then we created a prototype. We did these designs through rapid prototyping. So on above here, you see our sort of the original design that was there before our change or redesign. And later, what we did was to enable easy sort of understanding of what the properties are. We actually pushed them the names of those key properties into the titles, so you can easily see from the line titles what those properties are, and you don't have to actually dig deeper. And then to enable actual documentation itself, we created discrete fields. We realized that during the user and task analysis, we realized that sometimes these documentation can be done by nurses who may not have access to all of the information that they need, but they may need to actually make this documentation so that they have a line in place that they can use to give medications and use it further. So we allowed our design to say unknown, so that they are not fixed to selecting one of the options, but they can select unknown, proceed with what they want to do. And then the people who have knowledge about the lines, who can sort of maybe verify and see the line to see what it looks like, can then go through a list of all the patients for whom there was incomplete documentation. They can then go through this a list of patients and create that documentation that is necessary for further care. And by doing this, we actually were able to improve expert agreement on what the properties are. So before we did this intervention, only 40% of the line properties were agreed upon by experts from what was documented in the EHR. And then after our intervention, it increased to 83%. Similarly, the perception of the key properties by the nurses who care for these lines also increased drastically. And the ease of use of both the documentation and for reception of the information also increased significantly. And we have now made this sort of as a process into our hospital operations, where we are trying to actually do these rapid prototyping and in situ testing to make sure that it fits people's workflow and that we are building things that work for them. And these are some of other example projects that we have done that have been published. And sort of, I just want to reiterate the process. Always, we need to think about what the problem is, because oftentimes we may be trying to design or create a CDS for a problem that it is not suited for. So for example, if you're thinking about clinical deterioration, maybe recognition of if a patient is at risk for clinical deterioration is not what they need support for. They need support for actually trying to do things much more faster when they know somebody is at deterioration. So it depends on what the task that we need to support that would determine what kind of decision support that we want in place. And once we know what kind of things that we want to support, then we can create prototypes and then test it out with users and then make sure that it works for them. Sort of some few key sort of takeaways. One, technology is useful, but it's far from perfect. And we have seen how unintended consequences, how many unintended consequences we have with these systems. But technology is only one aspect, and technology may often fail because of the lot of interactions that we have in the work system, and we need to understand how things interact. And we as humans are fallible and can make errors, and this is by design of how we process information and do things. But some of the errors that we make are often a symptom of poor design. And if the system is designed in a way to compensate for some of the limitations that we have as humans, then we may not have those errors in place. And then applications of these principles, as I talked about, will help reduce some of those errors. And I want to sort of bring this point that, yes, the electronic health records that we have from vendors are probably limited in terms of what they offer, both in design, UI design, or like capabilities that they offer. But if we adopt this process to any design that we try to do, like customizations, like especially the CDS, like alerts, orders, and things like that, then we can improve usability and efficiency by making sure that it fits people's workflow. With that, I would like to thank everybody for listening to this presentation, and I'm happy to take questions.
Feel free to put your questions, either you can use the chat or feel free to unmute yourself, or you can also use the Slido, but I think that whatever. And I guess how did you get into this area? Because I know that we're happy to have people work on this area, and I see you come from the more Ph.D. industrial engineering background.
Yeah, so human factors is actually one sort of subset of industrial engineering. We don't yet have like PhDs in human factors as a program, but it's like a specialization within industrial engineering. And then I came to this by when I was doing my master's. Actually, I took a course on introduction to US healthcare system, and that's when I actually thought how much more we can probably do to help improve things. And so that made me think about healthcare as sort of a place that I want to work on. And then for my PhD, I started working more on electronic health records and studying usability issues with electronic health records. So I interned at MedStar, and I worked with Dr. Raj Ratwani and his group, and we sort of identify a lot of usability issues with electronic health records. And then during that time, I realized, it's not enough that we just say that there are usability issues. We have to actually improve them. And it's going to take a long time for us to, expect just the vendors to do everything for us. And so as I sort of took this job, I was sort of more focused on how do we do things within the hospital that can improve, because it's more in our capabilities to do.
Yeah, thanks for that. And yeah, there's a sense that we feel like maybe our hands are tied a little bit because of the constraints of the system. And Dr. Samino has a question. Can you say a few words about the methods, technologies for gathering observational data?
Yeah, there are a couple of ways we can do this. One, so in terms of actual electronic health record usage itself, we can do like quantitative sort of querying of the electronic logs, and that can give some sort of idea of how people use it. But if you are looking for a specific piece of decision support that we are trying to build right now, then what we usually do is we build it in a test environment. We come up with those scenarios that we want to do, and then we go to actual users. We ask them to perform, like, let's say if it's about using an order set, right? Like we would ask them to actually place orders for a hypothetical patient scenario. We will actually observe them. We'll ask them to think aloud as they go through. So that helps us to actually get into sort of some of how they are thinking about it, what things are challenging to them, what things are making them not comfortable with doing things, or what things they are struggling with in terms of finding information. And that helps us to reiterate on our design. Sometimes the way in which we have worded things may not make sense to them, so we may have to sort of just do some minor modifications, and that can actually have a huge impact on how people interpret and use a piece of decision support. Sort of little things as we do. And then in terms of actual observations itself, we would come up with a list of, and that is one of the things, we would come up with a list of problems that we anticipate this piece of decision support is going to have. Or if we have a specific set of goals that we think the CDS is supposed to achieve, then we would look specifically to see if users are able to get to that during those observation sessions. So it's just sort of being more attentive when we do the observation session and knowing what we want to observe on. Because when we go to observation sessions, usually there are 100 things that happen. It's important for us to know what we want to observe and then actually do that. And then post observation, we can have interviews or informal conversations about what we observed and getting feedback from them on if our interpretation of what we observed is what actually happened. Because that can also, one of the things that can happen is I observe and I assume that they did something wrong, but probably they were looking at something else. So those are some of the things that might help. Did that answer your question? In terms of technologies, yeah, and in terms of technologies itself, because I'm doing this in situ, it's not like a fancy thing to use like sensors or other things. But if you have sort of access to some of both resources in terms of both sort of financial and also human resources, then you can do have sensors placed on people. You can do like observing using eye tracking, right? And see if people actually look at certain things and if they actually perceive that information. You can actually also do like keystroke and mouse capture data that can actually see what, where did they move the mouses. You can, after you have the session, you can actually see like the mouse track of where people are going to see their navigation patterns. And that can help you think about how you want to set things up for easy flow based on how frequently they go, or like the order in which people use things and things like that.
Other questions? I have one final question then. We all know how hard it is to get things changed, and hospitals tend to be very conservative. And
yes.
So I'm kind of thinking, what are some of the barriers? We probably know some of the barriers to getting these things implemented in the real world, and how do you work to overcome those? And you probably collaborate with clinical teams. I'm just kind of curious about how that goes in the world.
Yeah, I actually have to give a shout out to one of our persons here. His name is Herb Williams. He is on, we use Epic here. So he's on Epic support team here. He helps providers or clinicians with like support on any problems that they have with Epic generally. And so he sort of knows most of the people. And so what has helped me is, in terms of doing the actual user testing, is one of the challenges with user testing generally is actually participant recruitment. And we have had great success with that because he sort of knew people, and he knew times when we can probably grab them for like 5-10 minutes to get feedback on a piece of decision support. So every week we take like a time that we think would probably work. It depends on what unit we want to test this on. Like if this is like inpatient floors, then probably afternoons are better. If it's like in the ED, we may want to do it like in the early morning when there is not probably much rush and things like that. So we know when we can go and get this user testing done. And once we have this user testing and feedback, the operational stakeholders are actually very welcoming to the feedback that we get, because they know it's very crucial to get feedback from front lines. So once we show them how the feedback sort of either changes of what our initial design was, or whether it confirms that what we came up is initially good, then it allows us to make changes that we want. And it also gets buy-in from people who are opposed to an idea. The CVAT documentation that I showed you, we actually had, the initial request that came was actually to redo the whole way we do documentation and create new line items. Like the build for that is going to be too much. And it would also make existing documentation of existing lines to be redone, which is a huge work. But we did all this process and we showed our new design work, and that actually helped them change their opinion on what the design should look like. And that helped.
Okay, great. I think that, sorry for running over. I hope that's
sorry.
okay.
Yeah.
No, that's okay. I just have, and also how do things get in your queue? Do people submit things that they say that are problematic? Are people seeing some bad outcomes?
Yeah, the way this works right now is we have like a clinical decision support request process, and that gets it's a bit involved process. So it first gets into as a ticket, and then it gets sort of discussed in our clinical decision support sort of meeting or committees, and then we get this to a prioritization committee that has stakeholders like our quality leader for our electronic health record, like CMIO, and people who have operational say on things, and we get things prioritized based on how important the problem is, how much involved the effort is going to be, and things like that. And that determines how we prioritize those requests. And once we have something that is prioritized, we just have a work process that looks very similar to what I showed you in the human-centered design process, where we think about what the problem is, we understand what it is, and then we come up with an initial solution. We take it to the stakeholders to do like a sanity check. Then we do user testing, simulate it, and then do some rapid prototyping. One of the good things is I am trained also on a build of electronic health records. And if there are things that I cannot handle, I often take our builders along with me for those sessions, and they can actually make modifications to the build between one user testing and other user testing. And that way we can sort of do rapid prototyping, and then we come up with our sort of what we did for our design to the stakeholders. We get approval, and then that goes into production. Certain times we also run things in background to make sure how often something may fire, or to make sure it works fine. But that's sort of the general process.
Wow, thank you for sharing that. I'm glad to see that the work that you do seems to be very much valued, as it should be, and trying to really improve the usability, because the general sense is that not much is being done about it, and it's kind of it is what it is. This is as good as it gets. So I'm glad that you're there working towards that. And I hope that becomes more widespread. Also, you're doing research to see what works best. Well, anyway, thank you for everybody for sticking around, and
thank you.
And you for answering all these
thank you. And if you have any questions, even feel free to email me in the future if needed. I'm happy to help or consult on things if needed as well. Thank you.
Yeah. All right. Well, goodbye, everybody. Have a great weekend, and look forward to seeing you at the next talk.
Thank you. Thanks, everyone.